So, hello everyone. This is the second part of the attribute charts, and here we are looking for counts of the non-conformities. So what it means is that the parts can be used. In the previous case, the parts cannot be used, but here parts can be used. And then here, in this case, we count the defects. This is very important. In the previous case, previous charts like the P, NP and the percentage charts, we were counting the defective products, not defects. That's very important. So I will first start with the C chart, and the C chart means that we will use one sample size, the sample size of one. So we will take only one sample size, and all non-conformities have the same weight. So we don't give, for example, different weight to indentation, different weight to dents, different weight to discoloration, whatever. All non-conformities have the same weight, and then area of opportunity is large, but the probability is low. So for this one, you have to check the Poisson distribution. But for a reminder, I can say that this is like I gave an example for a pump. Pump runs continuously. All the day, all the year, the pump runs. There is a great opportunity for the pump to fail, but the probability that it fails is very low. So failure is 0.000, for example, 5. You see, it may fail anytime, but the failure rate as a probability is very low. That's where we use the C chart. These are the formulations that we use: the C bar, the upper control limit, and the lower control limit. And then C, as I said, is this one is the number of the non-conformities, or you can say the number of the defects. Okay. So the problem says that we have 20 feet length and 15 feet width paper roll, and it is continuously manufactured. We select one paper roll. You can see the sample number is 1, and there is one sample size is also 1. Sample size is 1. Okay, and then we check for like discoloration, inconsistent paper thickness, and moisture content, whatever, and then we show them as C. So this one is the number of defects, I will say. How many defects are there? So there are 12 defects. Like you can see, the part is big, so part is large, so therefore opportunity is high for defects. But the real case, the probability for defect is low. You can see it is 12, 11, whatever. It is a very big space, but there are small amount of the defects. So the question says that we need to draw the C chart and explain what's going on. So let's do that. These are the same data. I will just use the formula. Average C, we need to find. C bar is the sum of the C's divided by the M. So for that one, I will find the M, and the M is equal to number of samples, which is 15. Okay, and then let's start. C bar will be the sum of the C's, the number of the defects, and then divided by the M, 15. Okay, and then this one is F4, this one is F4, and then F4. Okay, Next comes the upper control limit, UCL, and that will be equal to, so C bar, so actually this one, there is, I should correct it, here there is this sign and then this sign, okay, so you have to be careful here. So it will be that this one plus 3 times the square root of the C bar, okay, and then lower control limit will be equal to the same 9 minus the 3 times the square root of the C bar, okay, and this one is 0. Okay, then we have to insert our plot, and then we select the data, and then we add the x values, which are the samples, and then y values are the C values, the number of the defects, okay, and then we add the upper control limit, which is this one, we add the lower control limit, which is this one, sorry, lower control limit, which is this one, and then we add the center line, which is C bar, okay, add the center line here, which is the C bar, okay, and then okay, so let's make them as a solid line, format it, and then solid, this one as a solid, and this one as solid line, okay, let's copy and paste it here, and then see how it looks like. Let me add a new presentation here, okay, and then if you check it, so this is our upper control limit, UCL, this one is lower control limit, and this one is the average, and these points are the C values. As you can see, it looks like a random plot, so we check that the C values are, this one is very important, that is randomly distributed about the C bar. If they are not randomly distributed, then it means that there is an external reason, and you have to identify that reason, and you have to eliminate that reason for the defects. So what we want is that the reason for the defects should be random. It should not be something that external. So let me just show you that the reason for defects should be random. Okay, this is very important. So it looks like a random distribution, everything is in control, and then we can be sure that we don't have any assignable cause or reason, external reason, that causes the defect, like the operator problem, the machine problem, whatever. That is the end of the C chart, and next recording I will talk about the U chart.